In exercise 3, we're going to be looking at the microscope and learning how to use it. A couple of the terms used with it. Resolution, that's just referring to the ability to see very fine detail and see two separate objects as two separate objects. The working distance, that's the distance between the bottom of the objective lens to the top of the slide that you're viewing. The field of view, that's the area of what you see when you're looking through the ocular lens, which is also known as the eyepiece. So what are you actually looking at? Parafocal just means that when you get the specimen in focus and you go to switch to the next objective lens, it will still be there. Now, it may not be nice, fine, crisp, clear focus. It might be a little bit blurry, but you will still be able to see it. That's what parafocal means, and all microscopes are made that way. So when you switch to a higher objective lens, you don't have to start all over again with trying to find your specimen. The total magnification, often abbreviated as TM, that is just simply the magnification of the ocular lens, which is the eyepiece, times the objective lens. So you just multiply those two numbers together to get your total magnification. So as an example, if the lowest objective lens is in place, what's going to be the total magnification? Remember, you just multiply the two numbers together. So if the lowest objective power in place is, if the ocular lens is 10 and the objective lens is also 10, you multiply them so it'd be 100 times. In terms of the parts in the microscope, you have several different components of it you need to be familiar with. The base, you have the substage light in the microscope, compound scope, or light microscope that we typically will use in our teaching labs and in clinical labs. The light is underneath the stage, so we refer to it as substage, and it shines up through the specimen. You have all of your controls for your stage, such as being able to move not the entire platform, but you'll be able to move the slide left to right and front to back. You have the iris and the condenser. These are helping to concentrate the light through the specimen and also controlling the amount of light that's coming through. Your objective lenses and then your stage. You also have the rotating nose piece where the objective lenses are attached to. You have the arm, the stage itself. You have a condenser knob. You have a coarse adjustment, a fine adjustment, and then the light control. Now, some of these controls are a little bit different from one brand of microscope to another, but they're relatively the same. It just isn't in the front or the back, on the side. And you do need to be familiar with where they are. To determine the field diameter, this is, as you increase the magnification, your field diameter is going to get smaller, that area of what you're looking at, because you're magnifying it. And so you can calculate what the field diameter is. Usually what happens is for one of the field diameters, you're going to have to actually measure it. We take a ruler, we place it in place of a slide on the microscope, and we actually measure this. You take a ruler and it might be, say, 5 millimeters across the diameter. And so what this would mean is that when you are looking through the microscope, and trust me, I can't draw, if that's what you're looking through, that's what you see, what is this distance across that field of view from one end to the other? That would be your field diameter. So you would actually measure it, typically at the lowest objective lens. And in this case, I'm giving an example where it was 5 millimeters. So the distance from here across to here is 5 millimeters. What is the total magnification when using that particular objective lens? In this example, I'm saying it was 40. And if you want to figure out what is the field diameter at a different objective lens, in this case for B, which the total magnification is 100, I'm showing you the formula that you would use here. So what you would do is you would take that field diameter right here, which you measured, you multiply it by the total magnification, which we have right here. You divide it by the total magnification for the one that you're wanting to figure out what the field diameter is. So you go 5 times 40 is 200, divide it by 100, and that gives you 2 millimeters. So that means at this higher magnification, the field diameter is smaller. And that's exactly what happens.